Okay, on this, we're going over our library of functions, and you do need to have these memorized. So it is important because when you start to shift graphs and move them around, transform them, if you already have an idea of what the graph looks like and what a few points are, it just makes things a lot faster and a lot easier on you to have these memorized. So for our first one here, we have just a constant y equals b, and that is just going to be a horizontal line, and then we'll label our point. We don't know exactly what it is, how far up it is on the y-axis, so we call it b. We just call it 0, b. Our second one is the identity function, y equals x. And so this is just like our diagonal line, and we're going to have 3 points for this one. We have the origin. That's always the easiest. And then we're going to have a point that goes through 1, 1, and a point that goes through -1, -1. All right, then we have the square function, y equals y squared. Hopefully you remember this is quadratic. It's going to be a parabola. So we have the point 0, 0. And on some of these, I like to draw my points first because it helps me sketch my graph a little bit neater. And then these points, remember, they're reflex of each other, but this point out here is going to be 1, 1. This point over here is going to be -1, +1, and then this gives us our parabola. So you should have that rounded shape there at the bottom. Okay, so that's our square graph. Then we have the cube graph. Okay, so again, now a lot of these are going to have very similar points, or like same points. So we have 0, 0. We're going to have 1, 1. We're also going to have -1, -1. So here are 3 points for this one. And this one kind of curves, and it looks like that. Then we have our square root graph. So this one starts actually at the origin. It starts at 0, 0. And we have the point at 1, 1. And we have a point at 4, 2. So it starts here, and then it's just going to be going up forever. So it almost has that square root look to it. Like you can see like it's got that part to it right there. That's kind of how I memorized these when I had to memorize these in high school. All right, then we have a cube root graph. So again, we have 0, 0. We have 1, 1, and we have -1, -1, and so this one is going to look like that. Hopefully you can draw yours a little bit neater than mine. Okay. All right, our reciprocal graph, y equals 1 over x. So since this one is a fraction, we do have asymptotes on this graph. So I'm actually going to draw my asymptotes first. So I have an asymptote at x equals 0, and I have an asymptote, a horizontal asymptote. So that was my vertical asymptote. This is my horizontal asymptote at y equals 0. And so my graph, I've got a point at 1, 1, and we're going to do another point here at 2, 1/2. And then our other point, we're just going to do one point down here, but notice it runs right up next to the dotted lines, and make sure your graph does not cross the dotted lines. Those are your asymptotes. So that point was -1, -1. All right, our absolute value graph. We have 0, 0. Again, we have 1, 1. And again, we have -1, +1. So notice how a lot of these use the same points. All right, and this one is shaped like a V. It does come to a point, unlike the square graph or the parabola. All right, an exponential graph. So this is where, depending on kind of how steep it's going to get, or where it's going to, not how steep, but where the graph is going to be moved. The first thing I am going to do is I do have an asymptote. So I have a horizontal asymptote at y equals 0. And then my points are actually going to be on this one. I have 0, 1. And then I have 1a, depending on what a is. And then I have 2a squared. Like if you plug in a 2, you square a. If you plug in a 3, you'll cube it, and so on. And so this one is going to look like that. Okay, the last one is called the greatest integer graph. So it can be written, you may see it with brackets around the x, or y equals the int of x. Another way that you may also see it is like that, okay? So let me show you the graph first, and then we'll talk about what exactly this means. So I always like to start on the origin. So I'm going to have a point at 0, 0, and I'm going to have a hole at 1, 0. And this is what I like to call, I've always learned this, I've called it the step graph because it looks like steps. So I've got this one started on the origin. I'm going to go one step above, one step below. So the step above, I've got my solid point there and an open circle. So solids are always on the left, my open circles are on the right. And then this point is at 1, 1, and this point is at 2, 1. And I'm going to go one below as well. So open circle here, closed circle here. So you can see it kind of looks like steps. And these coordinates are -1, -1, and this one is 0, -1. Now, this graph could keep going forever, but we're just going to do these 3 parts. But I could keep going up with my steps. I could keep going down. So let's talk about what exactly this means. What is the greatest integer? Or what is the greatest integer graph? So think of it like this. If you have, if we're going to take the greatest integer, 3.7, okay, think about that on a number line. What is the greatest integer that you've passed on a number line when you get to 3.7? So if I do my number line, okay, so 3.7 is going to be somewhere right there, okay? So think about as you're approaching 3.7, as I approach it, what is the greatest integer that you pass? Well, the greatest integer is going to be 3, okay? So let's do a negative number. Let's say we have the greatest integer, -2.1. Okay? So think about where 2.1 would be on the graph. So 2.1 would be, -2.1 would be about right there. So again, as you approach it, as you're still going this same direction, what is the greatest integer that you pass before you get to that? Well, the greatest integer that we passed is -3 in this case. So that's what a greatest integer means.